Hi everyone, I hope you had a wonderful 2 weeks off and a great Christmas and a Happy New Year, and you got to relax a little bit and spend time with family. Time to get back to the grind. I cannot wait to see you guys tomorrow. Today what we're going to be doing is you're just going to be reading out of the book. So if you could follow along, and then you will have to answer the questions that go along with the reading. But I will read to you so you can just follow along. We are starting our weathering, erosion, and deposition unit, and we are going to read pages 124 through 133. So I'll give you a couple seconds to go ahead and open up to page 124, and that's where we will start. Okay, so on page 124, what can break a boulder? When you think of rocks, words like hard and solid may come to mind. You may think rocks can't ever break, but that's not true. Wind and water can slowly change and shape rocks. The roots of this tree broke apart in the rock. When it rains, water can get into the cracks of rocks. When water freezes to form ice, it expands. This widens the crack. You've probably seen that in sidewalks before and never even realized it. When water freezes again, it pushes the cracks in the rocks even wider. When this happens many times, the rock breaks apart. On page 125. The process of rock breaking apart is called weathering. Many different things can cause weathering. Flowing water can cause rocks to tumble and scrape against rocks in the riverbed. Sand blown by wind can scrape against rocks. Living things can also cause weathering. A tree's roots can grow in a small crack in a rock. As the roots grow, it can push the rock apart until the rock breaks. Animals may dig up rocks, causing the rocks to be exposed to wind and rain. Chemicals in water and rain that flow through and around rocks can also cause weathering. These chemicals can combine with the rock and change it so that it crumbles and wears away. Look at the statue on this page. Chemical weathering has already changed one of the statues. How will weathering change what this statue looks like? Observe the statue. Describe how it might look in the future. Okay, so look at the statue right there, and then what do you think might happen in the future as weathering could possibly occur? So you can either answer that now or you can come back to it in a few minutes. Page 126, rocks on the move. Don't rocks just sit around in the sun all day? Nope, rocks can move. Find out how. Weathering is the beginning of a series of slow changes that often occur to rocks on Earth's surface. The same wind and water that can cause weathering also can carry the broken bits of rock away. The process of moving weathered rock from one place to another is called erosion. The erosion of rock is caused by many different natural processes. Moving water is one of the most common causes of erosion. The fast-moving water in the stream can shift or move large rocks near the top of the mountain. Together with gravity, water can cause the rocks to move downhill. The water pulls the larger pieces of weathered rock along the river's bottom. As the water slows down, it has less energy. It cannot move the largest rocks and pebbles. These are left behind as the water moves. The dropping of weathered rock by wind or moving water is known as deposition. I always think of dropping into a new spot starts with a D. Deposition starts with a D. What happens next? Observe these pictures of the Yangtze River before and after a dam was built across the river. How do you think the dam affects the movement and deposition of sediment by water? So look at the before picture and the after picture and go ahead and you will have to answer that. What effects do you think cause that? As the water in a river continues to slow down, more bits of weathered rock are dropped. This happens because slow-moving water has less energy than fast-moving water. So slow-moving water can carry only very small pieces of rock, such as sand and silt. These bits of rock are called sediment. When rivers reach the ocean, they slow down even more. As they slow down, much of the remaining sediment in the water is dropped. Over time, the sediment piles up near the mouth of the river. It forms a landform called a delta. on page 128. Blowing in the wind. Wind is just moving air, so what can it do? A lot. Wind can pick up and move sand and other sediment. A landform is a natural land shape or feature. Weathering, erosion, and deposition by wind slowly form and change landforms. Wind can erode sand, moving it long distances. When the wind deposits a lot of sand in one area, sand dunes form. Sand dunes are often found near sandy beaches, but dunes also form far from oceans. The dunes of some deserts span thousands of kilometers. The shape of a sand dune constantly changes. Wind sweeps up one side of a dune and lifts sand from its surface. Then, gravity pulls the sand down the other slope. An entire hill of sand gradually advances this way. Blowing sediment can also cause changes to other landforms. Particles carried by wind collide with exposed rock and cause weathering. Exposed rock can slowly erode, leaving interesting shapes. Mushroom rocks and arches are formed by water but shaped by the wind. Over time, they become thinner and more fragile. Eventually, gravity pulls these formations to the ground. Observe the dunes. Describe how the wind affects the direction in which the dune moves. Okay, so you can go ahead and pause the video and answer that question, or you can come back to it later. Page 129. So look at the wall arch, okay, before, and then look at it after. Observe the photograph. Write a sentence that explains what shaped it. Then list 3 processes that caused it to collapse. Make sure you list 3 things. Page 130. Ice carvings. Huge sheets of ice are called glaciers. Glaciers are found in very cold places. Because glaciers are made of solid ice, you may think they do not move, but gravity pulls glaciers downhill. The ice flows like a very slow river. Glaciers can weather, erode, and deposit rock. A glacier can pick up rocks as big as school buses. Holy cow. Think of 2 ways gravity helps glaciers shape landforms. Page 131. As a glacier moves forward, it pushes boulders against the ground beneath it, scraping and scratching rock. This can slowly change the rock by carving deep glacial grooves into it. The grooves can be seen when the glacier melts. As the glacier begins to melt, the rocks and sediment it carried downhill drop out. The deposited sediment forms different land features, including hills called moraines. In the distant past, much more of Earth's surface was covered with glaciers. A huge glacier once covered most of Canada and northern United States. The ice cut deep grooves that filled with fresh water as the glacier melted. This formed the Great Lakes. The largest, Lake Superior, is more than 400 meters deep in some places. Look at that picture of glacial grooves on Kelleys Island. Those were formed when ice eroded from the rock. So Kelleys Island is super close to us. I wish we could take a field trip there to see them. As glaciers' front edges move downhill, it is said to be advancing. A glacier that melts faster than its front edge advances is said to be retreating. Look at the data in the diagrams. Identify which is advancing and which is retreating. So if it's melting faster in the front, it advances. If it does not, it is retreating. So one will be advancing and one will be retreating. And our last 2 pages. Can waves cut caves? Moving water causes weathering and erosion. A flowing river picks up sediment along its path. The rushing sediment scrapes against the bottom and sides of the riverbed. This weathers the material along the river's paths even more. River water can carve deep canyons. A canyon is a gorge between cliffs of rock. Deposits of sediment can build up and force river water to change directions. Curves in a river's path change over time and produce different landforms. Observe the images of the sea arch and the canyon. Identify how water caused these landforms, then describe how these causes differ. Okay, so you're going to have to look at the pictures on page 133, okay, to answer that question. On page 133, ocean waves crash forcefully into rocks along the shore. The waves weather cliffs, erode away pieces of broken rock, and deposit the sediment in new places. Waves can cut caves into the shoreline cliffs. The sediment from eroding shorelines become fine particles of sand. Beaches form where the sand is deposited at the water's edge. So now looking back up at that beautiful picture of the sea arch, what do you think will eventually happen to the sea arch? And explain what you think is going to happen and maybe why. If you did not stop, if you did not pause the video where the questions were, you do have to go back and answer those questions. We will be going over them in class, and I will be taking a classwork grade for it. So if we look back, we started on page 124. So there is a question to answer on page 125. So that's one. There's one on 127. So that's two. There's one on 128 and 129. So that's four altogether. There's one on 130 and 131. And 132 and 133. So you have about 8 questions that you do need to go back and answer within this reading if you did not stop the video and answer the questions as you went along. Okay? If you have any questions about this, like I said, we will be going over it in class, but I do want you to try it on your own first because, like I said, I will be giving a completion grade on it to make sure that you are doing what you're supposed to be doing today. I cannot wait to see you guys. I can't wait to hear about your breaks and all of the relaxing that you got done. I do want you to say hello to Cammie. She's taking a little nap. Cammie. There's little Cammie. She hopes you had a great break too. She got to relax a little bit. Okay guys, I hope you have a wonderful day and I will see you tomorrow. Bye.